Here are solutions to homework set number 9 for ECE 476, 676 Advanced Embedded. This homework set asks you to use a GY521 accelerometer along with your 52Pi board and a NeoPixel to do something. In this solution, I'm going to build a bubble level. So what the bubble level does is something kind of like this. I've got my accelerometer over here. So here's the accelerometer. As I tilt it, it shows the acceleration x and y. When it's right in the middle, 0g or flat, then the LED comes on. So procedure to do that. The first thing I need is the hardware. Connect up the accelerometer to your Pi Pico, and actually I'm using 3.3 volts. It's got two-way communication, prevents you from actually damaging the Pi Pico. Actually, Pi Picos are pretty tough, it can handle it, but you're not supposed to. In terms of software, once it's connected, I want to make sure that the Pi Pico is actually talking to it. So that's where you write little test routines. One test routine, let's stop this guy, is to first see, can I communicate with the device? So, where are you? Here's a little test routine. All it does is check, is there a device on the I2C bus? If so, print it. So as I run it, it says, yep, I found it. I have device number 104. That's a GY521 accelerometer. Okay, now that I can see the device, let's see if I can read it. To do that, I'm going to use I2C communication, set up the I2C bus right here using pin 0 and pin 1, instance number 0. I'm going to define a couple of routines to read the I2C registers, to write to the registers, and read the acceleration. I will set it up. I'll first set up the bandwidth. If you go through the lecture notes on Bison Academy, address 1A sets the bandwidth. 5 Hz is the number 6. 2G acceleration is the number 0, is written to address 1C. And 0 to 6B sets the clock frequency to 8 MHz. I will then read the XYZ acceleration, and here's what that looks like. So I'll run this routine. I'll look for the device, if communicating with it, read the XYZ acceleration. And there you have XYZ. So turn the accelerometer around, numbers are changing, and it seems to crash. I'm not exactly sure why it's crashing. I can fix that with a try again command. But there, it seems to work. Okay, next. Now that all works, let's add the NeoPixel routine and the graphics display routine. So the blue part is I2C communication, stuff we've done before. The NeoPixel, I'm going to be using the bitstream way to drive the NeoPixel. Here's the timing on the NeoPixels, off time, on time, logic 0, logic 1. Define a couple colors. There's the green, red, blue, percentage. I will talk to the LCD display, draw the crosses, and then over and over again, read the accelerometer, clear out the old cursor, draw the new one. If I'm within 1, make the NeoPixel red, 5, make the NeoPixel green, and repeat. So trying that. Turn off this one, turn on the main routine. Okay, so for example, if I make the bandwidth to 50 Hz, that's a 0 right here. Here's what she looks like. It's quite a bit noisier. As I turn the accelerometer, it's showing the position with a lot of noise. Change the filtering back to 5 Hz. That's the number 6, written to address 1A. I get a cleaner response. And you can also add more filtering and software, but that's the built-in with the GY521 sensor. finally, if I get the crosshairs right in the middle, which is not that easy, you'll see the NeoPixel turn on right here. I think it's not there for a second. So finally, to validate that it works, the main loop takes 12.358 milliseconds. I found that by using the ticks microseconds command inside the loop. The sensor is acknowledged. It's read as hex 68 or decimal 104. I'm reading the XYZ acceleration. The graphics display is working, showing crosshairs where the acceleration is and my 0 position. The NeoPixel is working. When it gets within the middle, the NeoPixel turns on. Kind of like that. So that's homework set number 9 for 476.